Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 15, using unique triangles to solve real-world and mathematical problems. Classwork 1, Example 1, a triangular fence with two equal angles. Angle S equals angle T. I'm not a real big fan of saying two angles are equal. Let's call it congruent. Angle S is congruent to angle T. So here's angle S and here is angle T. They're congruent. It's used to enclose some sheep. A fence is constructed inside the triangle that exactly cuts the other angle into two equal angles. So what they're saying is they built this fence right here. So they built this fence right here that split this angle R into two congruent pieces. So angle SRW is congruent to angle TRW. Show that the gates represented by SW and WT are the same widths. Okay, so they told us we are given two angles. So this is an angle and this is an angle, and we also have this fence that shares a common side of each triangle. So since I have an angle side and an angle side, then the corresponding, or the two triangles are identical by angle side. Or you could say two angles and a side opposite a given angle. So if the two triangles are congruent because of this, then everything is congruent. In other words, now that I know that the two triangles are congruent, I know that this angle and this angle are congruent. I know that this side and this side are congruent, and this is congruent to itself. So therefore, this side has to be congruent to this side. So since the two triangles are congruent, then SW is congruent to TW. Okay, example 2 says, in triangle ABC, AC equals BC. So AC is the same length as BC. And triangle ABC corresponds to a triangle B prime, A prime, C prime. John says that the triangle correspondence matches two sides in the included angle and shows that angle A is equal to angle B. And again, I don't like that word equal for angles. The measure of angle A may be equal to the measure of angle B, but angle A is congruent to angle B. I'm a little picky on that. All right, so anyhow, we are told that AC equals BC. This side equals this side, so I've marked that. The correspondence of triangle ABC to triangle B prime, A prime, C prime tells us that BC corresponds to A prime, C prime. Okay? And the reason I know this is because BC are the last two letters in the name of triangle ABC. Let me do that again. Right here. So the last two in this name are A prime, C prime. So therefore that's how we map B onto A prime and C onto C prime, by the order of what our names of our correspondence is. Okay, so there's one thing that we know. We also know that CA, all right, so now I erase these. So we're taking C and then A, so I would say C prime, B prime. CA corresponds to C prime, B prime. And angle C corresponds to angle, and then when I look up at this naming order, angle C corresponds to, that's the last letter in this, the last letter over here is C prime. So angle C corresponds to C prime, which makes them congruent. Okay, so that means that triangle ABC is identical. This triangle is identical to this triangle, B prime, A prime, C prime, by the two sides in an included angle theorem. So we have a side, included angle, and a side. A side, an included angle, and a side. So that's SAS. Two sides and an included angle. From the correspondence, we can conclude, since the two triangles are congruent by side, angle, side, then the corresponding parts of congruent triangles are congruent. So now I can say angle A, which is the first letter in our name, is congruent to angle B prime. And I'm going to change that from equals to congruent. If you're going to say equals with two triangles, you have to say the measure of angle A equals the measure of angle B prime. If you're just going to say angle A equals angle B prime, that just, you want to say congruent, not equal. The measures are equal, the angles are not equal because there are different locations, if you will. One's flipped over from the other. Okay, page 2, lessons 1 through 4, exercises. So these are exercises, so pause the video, see if you can answer them, and then unpause the video and check your solutions. So number 1 says, Mary puts the center of her compass at the vertex O. So I'm going to go through these little steps as they say. So what they're saying is she put her compass at the center vertex O, like so. Okay. At this vertex O of the angle and locates point A and B. So then she extended this out to point A, made an arc, and then did the same thing up here and made an arc. Okay, so that's the first step. Next, she centers her compass at each of A and B to locate point C. So then what she did was she put her compass at point A, like so, and created an arc from the center A with the same radius. So she's making semicircles, or not semicircles, but arcs from a circle, and they're all the same radius. So if the compass is never moved, every mark has this congruent distance, or their same distance from the center. So then she made this arc, and then on the step C it says she centers her, and then to locate point C. So we locate point C by where those two segments or those two arcs intersect. Finally, she constructs the ray OC through here. Now it says to explain why angle BOC is congruent. I'm going to put a congruent symbol there. Angle BOC, explain why this angle here is congruent to this angle here. Okay, so the reason is that, first of all, this distance and this distance are equal. So if I drew a segment from here to here, and a segment from here to here, now you can see I have a triangle and another triangle here. So what's happened here is, since OA is congruent to OB because we use the same radius from our compass, this is congruent to this. So therefore in this triangle right here, OA is congruent to OB. Then when she put the compass here and drew an arc from B through here, and then put the compass point here and drew an arc here and found the intersection C, that confirms that AC is congruent to BC because she used the same distance from here to here, same radius of a circle if we continue the circle all the way around. So we have two triangles with two sides, and then the ray OC that she drew is shared in both triangles. So the reason these two triangles are congruent is by the side theorem. We have all three sides congruent, and since we have three sides of one triangle congruent to three sides of the other triangle, then all the angles must be congruent, and therefore angle BOC is congruent to angle AOC. Okay, so here's the explanation. So if you want to read that, pause the video and read that, but I'm going to move on. Number 2, quadrilateral ACBD. Quadrilateral ACBD, okay, is a model of a kite. The diagonal AB, so let me draw that. The diagonal AB and CD okay, represent the sticks that keep the kite rigid. A, John says that angle ACD, which is right here, is equal, again, congruent to angle BCD, which is right here. Can you use identical triangles to show that John is correct? Okay, well, first of all, let me finish these. Let's draw a triangle and move it off to the side so we see what's going on. Let me choose this blue here. So if I drew a triangle from here to here, and then up to here, like so, there's one triangle. Okay, so what I've done here is I've outlined the two triangles. So now if I move these, like so, I've got this triangle here and this triangle here that came from the kite. Now if I label these, this was C, this is A, and this is D. This is D, this is B, and this is C. So in the diagram, we are told that AC is congruent to BC by this one mark right here. And then there's two marks on AD, and there are two marks on BD. That tells us that AD is the same length as BD. So we have two sides so far. This is a side, this is a side, this is a side, this is a side congruence. And then CD is shared, so therefore CD is congruent to itself. So those two triangles are congruent by the side, three sides theorem. And since that is true, then all the parts of a congruent triangle are congruent to all the parts of another triangle that are congruent to it. Okay, so two triangles that are congruent, everything has to be congruent. So that we can conclude that angle A is congruent to angle B, and this angle ADC is congruent to angle BDC, and ACD is, I should put two marks here, ACD is congruent to BCD. All right, so angle ACD is congruent to angle BCD because the two triangles are congruent by the side theorem. So yes, John is correct. Okay, page 3, number B. Number B. Letter B. Jill says that the two sticks are perpendicular to each other. Okay, we're still talking about the kite on the problem before. Use the fact that ACD is equal. That's really bugging me. Congruent to angle BCD, and what you know about the identical triangles to show angle AEC is 90 degrees. Okay, so here's the diagram, just so we don't have to flip back and forth. So she says that the two sticks are perpendicular to each other. Use the fact that angle ACD is congruent to angle BCD, as I've marked here already, and what you know about identical triangles to show that angle AEC is in fact a right angle. So that is this angle here. All right, so we already know that this triangle is congruent to this triangle. That's a fact, Jack. All right, so we have this side equal to this side. We already know that. And the length of this side is equal to this side. And this side is equal to itself. We already discussed that in the last problem. All right, so what else can we conclude here? How do we know these are perpendicular? How do we know they're perpendicular to each other, forming 90-degree angles? Okay, well, we can shorten the common side that they have. So we already know that this side is equal to this side. And now instead of using this whole piece, we're just going to focus on this piece. So it's shared, so it's congruent to itself. So we have angle, or we have side, angle, side. So this is a side, this is an angle, and this is a side. So by SAS, triangle ACE is congruent to triangle BCE. And since the two triangles are congruent, then all the angles in the triangle must be congruent. So angle CAB is congruent to angle CBE. And this angle here and this angle here must be congruent as well. Okay, so now we know the two triangles are congruent. Now we also can say that angle AEC is congruent to angle BEC. So let me clean this up a little. It's getting hard to see in here. All right. So what I'm saying is this angle here is congruent to this angle here. Fair enough, because the two triangles are congruent. But what makes them 90 degrees? Well, AB is a straight line. So if I have a straight line, and I draw an angle on it, like so, and I say they're congruent, well, this can't be 40 degrees and this 140 degrees. They're not congruent. So in order to make them equal, I have to cut the 180-degree straight line in half. Does that make sense? So if I cut the 180-degree line, a straight line is 180 degrees. If I take half of it, then they both have to be 90. And since they're both 90, they have to be congruent. They have to both be 90 degrees, and therefore that is why angle AEC is 90 degrees. Part C. John says that Jill's triangle correspondence that shows the sticks are perpendicular to each other also shows that the sticks cross at the midpoint of the horizontal stick. Is John correct? Explain. So now what he is saying is this point here is the midpoint of AB. Is he correct? Well, yes, he is, because if these two triangles are congruent, then AE has to be congruent to BE. So in answering this, we'd say, since we have established that the two triangles are adjacent to each other, we know that AE is equal to BE. This means that E is the midpoint of AB by definition of midpoint. All right, number 3. In triangle ABC, angle A is congruent to angle B, and it's marked. And triangle ABC has a correspondence to triangle B', A', C'. Jill says that the triangle correspondence matches two angles in the included side and shows that AC equals B', C'. So she is saying this is equal to this. Is she correct? Okay, so we're given angle A is congruent to angle B, and we have a triangle correspondence. So that means A corresponds to B'. So therefore angle A is congruent to B'. So I will mark that. A is congruent to B'. Angle B is congruent to angle A'. Angle B is congruent to angle A'. But they're congruent. Angle A is equal to angle B, or angle A is congruent to angle B, so I don't want to use two markers. That is still just 1 mark. But I'm just color coding them so that you see the correspondence in the name. And then finally, we know that angle C corresponds to C prime, and they also have to be congruent. I already used blue. So C corresponds to C prime, so that means this is congruent to this. So we have a triangle correspondence. We're told this right here. So since we have a correspondence that matches 2 angles in the included side, as shown that AC equals B prime C prime, okay, so what she is saying is the triangle correspondence matches 2 angles, angle A to B prime and B to A prime, and the included side, and shows that AC equals B prime C prime. Is Jill correct? So we are told that angle A equals angle B, is congruent to angle B. The correspondence of the triangles ABC to B prime, A prime, C prime tells us that angle A equals B prime, which I've already said, B equals A prime, which I've already said, and AB equals B prime, A prime. Okay? So that is the included side. This is congruent to this, which means triangle ABC is identical to triangle B prime, A prime, C prime by the 2 angle and included side condition. So we have an angle here, we have an included side, we have an angle. We have an angle here, an included side, and an angle, so that is angle, side, angle, ASA, or 2 angles and the included side. From the correspondence, we can conclude that AC is equal to B prime, C prime. Therefore, Jill is correct. Okay, page 4. Number 4. Right triangular corner flags are used to mark a soccer field. The vinyl flags have a base of 40 centimeters, which is marked here and here, and a height of 14 centimeters, labeled here and here. A. Mary says that the 2 flags can be obtained by cutting a rectangle that is 40 centimeters by 14 centimeters on the diagonal. Will that create 2 identical flags? Explain. Okay. So this is very wordy, so I'll just bring it in. Okay, so as I was saying, lots of words. If the flag is to be cut from a rectangle, here's the rectangle, both triangles will have a side length of 40 centimeters, a length of 14 centimeters, and a right angle. So what they're saying is this will be 40, and so that is, let me color code this thing up, that is this side right here. Okay, that's 40, and therefore this is 40, because by definition of a rectangle, opposite sides are congruent. Okay, so now I can label this 40 centimeters. And then we are told that this is 14, and therefore this must be 14. Because, let me fix that, by definition of a rectangle, opposite sides are congruent. So, if this is 14 centimeters, this is 14 centimeters. There is a correspondence that matches 2 pairs of equal sides and an included pair of angles on the corner flag, because this is a 90-degree angle. This is a 90-degree angle. Because, by definition of a rectangle, opposite sides are congruent and all 4 angles are 90 degrees. So we now have a side of an included angle and a side. There's other ways we could have proved this as well. Okay, so there is a correspondence that matches 2 pairs of equal sides and an included pair of equal angles to the corner flag. The 2 triangles are identical to the corner flag as well as to each other by side angle side. All right, B. Will measures the 2 non-right angles on a flag and adds the measurements together. Can you explain without measuring the angles why his answer is 90 degrees? Okay. Okay, and so the reason for that is he measures the two non-right angles on a flag. So what they're saying is he measured this angle here and this angle here, the two non-right angles, and he concludes that they add up to 90 degrees. So without measuring those, how can you prove that he's right? So if I take this triangle, this angle is right here, and this angle would also be down here if they're congruent, because of these two triangles being congruent by side angle side. Okay, this angle here is congruent to this angle down here, and this angle right here is congruent to this angle right here. All right, so since we know that these are rectangles, I know that this is 90 degrees. So those two angles have to add up to 90 degrees. So putting that into words, we say the two non-right angles of the flags are adjacent angles that together form one angle of the four angles of the rectangle. We know that a rectangle has four right angles, so